Okay, I'm going to go ahead and begin. So good morning, good afternoon, good evening, everybody. Welcome to today's webinar entitled Faster Big Data Analytics with MongoDB. If your travel plans today do not include exploring this topic, then please exit the aircraft immediately and see an agent at the gate. Otherwise, welcome aboard for about the next hour or so. This is Buzz Machete at MongoDB. I'll be joined by Amara at CIGNEX in just a moment. But first, let's talk a little bit about the logistics of today's presentation. So first, the webinar is being recorded, and you can ask the team at CIGNEX for a copy of that recording in about 24 hours. You can use the chat window in GoToMeeting at any time to ask questions. We're not going to answer them interactively. Instead, we're going to allow the set of questions to fill up, and then at the very end of the webinar today, we will tackle them largely in the order in which they arrived, but also the more popular ones will be answered first. A little bit about who's going to be talking to you today. Again, my name is Buzz Machete. I'm an enterprise architect here at MongoDB. Most of the time, I act in a pre-sales and strategy capacity with larger companies, and this is something of a career 2.0 for me. I was 25 years plus, with an emphasis on the plus, on the other side of the fence in financial services at JP Morgan and Bear Stearns. And at this juncture, what I'm going to do is turn it over to my co-presenter, Amara, who will tell you a little bit about himself, and then he'll take you into the meat of the presentation. Amara, do we have
thank you.
Yes,
we have
thank you,
Buzz. Great. Thank you, Buzz. Appreciate that. My name is Amara, and I'm the Vice President of Big Data Analytics and IoT practice at CIGNEX Datamatics. I come from a interesting background. Early part of my career, I spent a long time in chip design and embedded system design and EDA, electronic design automation, and that's where my passion for data came in. We would do a lot of analytics on, statistical analytics on chip yield prediction and so on. And the later part of my career, I moved, majorly into big data analytics and worked in the areas of healthcare analytics. And now I'm, heading the practice here at CIGNEX, working on a lot of big data implementations and a few IoT implementations as well. Again, 25 plus. I will not say 25 plus. Around 25 years of experience, and that's my introduction. So with that, let me, move to the next slide and, talk about the agenda, how we're structured for today. So here is what it is. We will essentially, I'll kind of refresh ourselves on the key challenges and opportunities of big data analytics. Then I will introduce the case study, which I'm going to present today, which is very MongoDB centric. And I talk about the business needs and, key business needs and how our approach was. A top-level view of the solution architecture and the key technology stack components therein, and to take you through the practical, implementation challenges we faced and how we kind of went over it. To give you a glimpse of what it took us to create this very large, in big data kind of large in terms of volume and variety both. Implementation in place, and what are the learnings from there, and talk a little bit about the best practices which we kind of have now institutionalized based upon our experiences working on this and maybe a few other projects. Then we'll move on to why MongoDB. Buzz will talk a little bit about that, and then I'll come back and talk a little bit about the company I come from, CIGNEX Datamatics. So. That's the packed agenda for today. We'll try to make good use of time, and that. Let me move to the next slide. So this is just going to refresh ourselves. I'm sure most of you people on the call today are this is pretty the big data is a huge opportunity given the fact that the data is growing exponentially, and our ability to kind of store that and analyze that is increasingly getting more and more easy. But what startled me is this research from IBM, which said that 88% of data sources and types are not being analyzed. Now that's a humongous opportunity lost and humongous opportunity present in front of us. So moving on, another study said that, again, this is again from an IBM around 2010, it said that organizations that use big data analytics as an integral part of their well-being, of their being, are up to 35x more likely to outperform their competitors. And look at the opportunity there in terms of improved customer experiences, reduction in operational costs. The opportunity is humongous in terms of you can just monetize information, improve risk management. It's like opportunity is humongous. But we haven't seen the proliferation as prolific as we would have hoped. So I'm sure there are challenges, and that brings me to the next slide. That what are the typical challenges in big data as we go from implementation to production? Now, some of it is well published in research, and some of it I've added flavor to our own experiences in the last few years, working with a lot of corporations trying to implement end-to-end big data solutions. So let me begin by on the technical side. I think the key problem which we face on the technical side is getting the right data and infrastructure architecture. Again, for performance and scalability to handle the variety and volume of data which we're going to handle. Now, add to that the complexity of the fact that there would be always legacy investments which every company has made. Now, if you want to start afresh on a clean slate, absolutely, we can get a very optimal architecture, data architecture, which is future-looking. But largely, people have made investments in legacy, and how do we the legacy investment and the new technology coexist and create some kind of a suboptimal solution, which is also future-looking in terms of the kind of data we need to handle and analyze. Of course, then there is this whole challenge about how do we integrate multi-channel and variety, which means how do we homogenize the data, how do we clean the data and get in a very homogeneous fashion, right? A whole data ingestion issue. Next on the list is, which I believe most people often undermine the impact of data quality. Significant amount of cost and schedule overruns are happening today because of issues in data quality. So having an eye on data quality and accuracy from day one and budgeting time and energy and money to handle that is an important element there. And we also know that the whole area as such is evolving so fast. The technologies are evolving too much. There was this Apache Storm, and this Spark, and there is MongoDB, there is Cassandra, which is right for me, which is not right for me. There's a flavor of the day, the technology comes in and loses flavor. So what do I latch on to? That's a huge challenge which everybody's facing, and every CIO is confronted with. And last but not the least is the scarcity of skills and capabilities. The fact that big data analytics today allows us to do a lot more than we were ever doing in business intelligence and insights. Also requires a much more sophisticated skill set, which is not very readily available. So that's a huge challenge as well. On the business side, what we have observed is, what my experience has been largely, always has been very difficult to work to justify a hard ROI in terms of top line or bottom line improvement. We all know that applying some of these big data techniques can reduce your risk and improve the customer experiences and so on and so on. But how do I really do a hard ROI on that? That's been a challenge in terms of monetization or budgeting in terms of budgets being available for implementing huge large big data projects, right? And second on the list is basically the whole turnaround time. From a full-blown production implementation of a big data, use case, starting with data ingestion, data cleaning up, and then of course there is a homogenization, and then there will be this whole thing of predictive machine learning models to be built up, and then deploying those models in production, which require applications to be incorporating that and whole validation cycle of those applications happening. In many of the cases, we've seen that entire cycle from the point of data ingestion starts to the point where these models can be deployed in production can actually be like 9 months or 8, 9, 10 months or to be of that order. And by that time, the data gets obsolete. So the biggest challenge is how do we do this entire thing in near real time, so that data continues to stay relevant, and incrementally these models are kind of enhanced as the data kind of keeps coming in and so on and so on. So that's been a huge, huge challenge, and we kind of try to address that in some of the approach we have taken on creating some platform for being able to implement some of these, end-to-end, big data projects. Of course, then there's a whole issue about, uncertainty in the data, which allows us to, which basically makes it difficult to make big data fit for the purpose and assess the level of trust, ensuring security, privacy, and so on. Right? And last but not the least, again, is, the lack of domain centricity. Domain expertise of the highest order is a very important element as we do some of these predictive models and so on. As one of the research talked about, that data science is now an intersection of, statistical, mathematical, skills, the hacking skills, software development skills, and third piece, which kind of is intersection, is on the domain centricity, the domain understanding. So that's been another, challenge on the business side. How do we kind of create that right team side, team structuring to be able to implement some of the big data implementation process. So with that, let me jump straight into the case study and talk a little bit about what this use case was, and how what are the key business needs, what are the key technology imperatives, and how did we go about delivering on those. So this was essentially the motivation was to the fact that a lot of public data is available. In terms of profiles of people, in terms of resumes of people, in terms of company data, company information, a lot of social media data is there. Now the idea is that if you can build up a SaaS-based sales analytics platform, which can ingest that data, homogenize, enrich the data, and then build a very intuitive analytics platform for salespeople to be able to improve the efficacy of customer acquisition. So which means that creating some business intelligence about competitive and complementary selling opportunities, getting a peek inside the companies or the potential customers, looking at understanding key influencers and decision makers, and even the buying propensity of the organization. So that would allow us to kind of create a much more effective, customer acquisition kind of strategy. So with that key business need, what was our approach? So the way we looked at it is, again, standard 4-stage process. We said the first process is data acquisition. So which means that we need to identify those, we actually have to talk about 20 plus different sources. Again, some of it's structured, some of it's semi-structured, some of it's unstructured. We're picking that data up in terms of acquisition, and of course, we were expecting that, we were expecting to kind of look at huge data science, up to 1 billion objects. Of course, after filtering and deduplication, the whole size may come down in terms of the persistent storage. But in effect, the processing we were expected to process about 1 billion per second. Once we did that, once we have done that, then comes the data preparation. So, and in this case, what I'm saying is, data. In our case, the data preparation and modeling kind of intertwined for the two phases. And what we essentially ended up doing is that as we are doing the homogenization and doing the ETL on this, variety and volume of data coming in, we actually leveraged the power of semantic association. We used NLP for unstructured data coming in, the textual data coming in. We did entity extraction, entity association, built a lot of entity association trees, and thereby enriching the whole information. We actually had a multi-step rule-based ETL process, and with a lot of proprietary algorithms we wrote to be able to kind of enrich the data so that the analytics of the front end could be very, very effective and intuitive, and so on. We also had plans, in fact, to kind of augment this semantic association-based stuff with machine learning algorithms in the longer run. And so that's the key USP in the entire scheme of things. And then the final process is the front-end analytics. This is a SaaS application which the salespeople would engage in. And of course, the key requirement there would be a very intuitive, front-end application with intuitive search and mining capabilities, and very nice UI, intuitive UI with dashboards and graphical visualization. And the key thing is the sub 5-second or 4-second response time, because anything more than that would disengage the salespeople who would want to kind of leverage this for the analytics. So in that, that's been the key approach how we kind of thought about the architecture and that brings me to the bird's eye view of how our architecture looked like. So it's a pretty unique way to look at it. The way we looked at the entire process was that there are two distinct pieces to the thing. That one distinct piece is the whole data acquisition and data enrichment piece. And that's very compute intensive. That is where we are running using some standard ETL tools like an Alteryx or a Talent or a Pentaho. Use that for doing standardized ETL process. Then we had a lot of custom, as I mentioned to you, algorithms, which were enriching the data, creating entity extractions, entity associations, and so on. A lot of that had to take place, very, very compute intensive. And and since we're ingesting, we are expected to ingest 1 billion plus records. The whole process, was expected to take, a matter of days. So it's not a matter of minutes or hours. It was a matter of days. Even in the high-end clusters. So high-end, cloud instances. So so what we essentially ended up doing, and of course the second piece was the front end, which meant that that's a SaaS application, very performance intensive in the sense that the response time being able to handle multiple concurrent users and giving a very fast response time. So essentially what we did is we ended up creating our architecture. We visualized two distinct subsystems. The first subsystem we call the ETL subsystem, which essentially was focused on just data ingestion and ETL and enrichment. So that's on the left side you see. So multiple data sources coming in, and that's where the backend ETL kind of subsystem was there. And then we visualize a separate subsystem for the front end SaaS application, which essentially was based on literally on the front end Java. We're using we kind of use a combination of the open source as well as some proprietary things like Jasper or DC.js kind of for visualization. And interestingly, and we essentially use two different clusters for the data processing part and for the data visualization or the front office part. So that is the key top level view. I'll talk a little bit more about the one box you're seeing in the front end, which is essentially the full text search engine. So besides the standard mining and queries from the front end application, we also have to support full text support, and we leverage some some technologies like Elasticsearch or Solar to be able to do that. So that is how our high-level view of the solution architecture was. So with that, let me move to the next slide. In terms of what was the key decision-making criteria when we chose some of the technology components, and MongoDB was one of the key because the key performance the key component from a performance standpoint would have been the data store, MongoDB, where the queries would be done regularly. So we felt it's a great fit, and I'm going to take you through some of that. Why I said that. So on the requirement side, on the ETL, which is the back end where we were doing the entire ETL processing, we needed to support multiple data processing pipelines. As I mentioned, we were using a combination of ETL tools. We were using a combination of custom Java code, which we had written for doing the proprietary algorithms on data enrichment. Then using custom scripts also. And MongoDB supports, very mature integration with leading data integration tools, Alteryx, Talent, Pentaho, and so on. So kind of fitted pretty well for us. The Java driver for MongoDB is pretty mature, and we were able to do, very effective custom business logic there using Java in Java. And it also supports server-side JavaScript to trigger custom business logic, and we kind of use that also pretty effectively. The next requirement from ETL subsystem was we needed to be able to sustain write throughput. Right? It was, as I mentioned, very write heavy. So the whole write throughput we need to kind of sustain with increasing data volume. So we expect. MongoDB again fitted very well, with sharding, with the very excellent sharding support to scale horizontally. With 3.0 and onwards in the White Tiger introduction, that came in very, very handy. Because of document level concurrency and the optimization they've done to the memory and hugely improved a write performance and data compression for both data as well as indexes for faster data access and efficient storage. So storage requirement also came to significantly reduced in Tiger storage. So again, it fitted very well for our requirements on the high volume and how throughput kind of how write throughput was very, very critical. Then on the front-end side, where the SaaS application was interfacing, the key requirement was to have low latency and support a large number of concurrent users while sustaining the response times of a sub 5-second or 4-second response time, even for the most of complex queries. So again, starting support in MongoDB came in very handy for distributing read requests to separate nodes. The data and index compression again in Tiger is very, very efficient. Came in very handy for us. And another interesting experience we had, and very positively enforcing experience was we actually stored indexes on separate disk mounts, and that significantly improved the read throughput. So that was again pretty interesting thing we did with our implementation. So in that case, the summary, MongoDB fitted very well for this for our needs here. So moving to the next slide, what were the typical implementation challenges? There are quite a few all across, and in the interest of time, I picked up a handful of them to kind of share with the audience today. So I think the first part was the challenge we faced was how to unify different processing components. So of course we use aggregation within MongoDB, but the whole efficiency of ETL, and even specifically during a development cycle. When you start an ETL process, it will take about 6 days, 5 days, 7 days, and something breaks in between, and you kind of restart it. So the whole efficiency of the development cycle was at stake. And we realized it the hard way, midway during the months after the project had started, and we started, doing some initial development tests and so on. So again, necessity is the mother of invention. We actually are very proud to have, implemented a very interesting orchestration engine, a very sophisticated and modular orchestration engine, which actually allowed full and partial execution of all data processing steps. In fact, it had a very nice dashboard which actually monitored each and every execution step and what's happening at every step. And you could restart, the process at any part of the process. And again, this is very generic. We kind of have, subsystem we created for orchestration. Very interesting, innovation there. The next part was about, as you would expect, given the fact that the whole front-end application had to be very performance-centric. So performance fine-tuning and the data processing and whole data processing analysis framework was very vital for us. And I'll talk a little bit more in depth on this one the next few slides as best practices. But the whole summary here is essentially we have actually created a very holistic approach to performance tuning. It is not about just going ahead and fine-tuning some indexes here or queries there or whatever. It is a full holistic approach, and I'll talk a little bit more about that in the next few slides. Next on the list is basically we realized as we were we started with MongoDB and the whole thing started putting up. We realized the full text search, there's a different use case of doing a full text search. So essentially we ended up utilizing complementary technologies, MongoDB for the persistent storage and horizontal scalability and analytics, and we introduced Elasticsearch or Solar kind of systems for doing full text use cases as well. Last on the list for today is again I'm going to allude to that again, and that's been a great learning for us. The importance of data quality, and again upfront when we started, we were picking up data, public data from a lot of different sources, and we underestimated the importance or underestimated or we were very bullish about expecting very good data quality to come in. And we are essentially hit by MARD in the initial phases by a lot of schedule overruns and so on. And largely, there are other reasons as well, but largely because of data quality issues. And again, through the project, we kind of realized that, made some course correction, budgeted a dedicated business analyst, and she's actually now responsible for the entire data quality and cleaning up. And that significantly allowed us to be more predictable in our releases. So with that, let me move to the next slide and kind of capture a few best practices which we have, learned over time, and specifically what learning we had from this particular project, one of the large implementations we've done on big data. So the first thing which I was alluding to it was essentially, about a holistic approach to performance tuning. Now, often you've seen that, you've done you've optimally utilized, done your queries and use the right indexes and so on, but still don't get the performance because, because the hardware and the infrastructure, your configurations are not in tune with what your access patterns are, what your use cases and so on. So our, holistic approach kind of, so we follow essentially a very holistic approach, starting from infrastructure sizing and capacity planning to operating system and storage optimizations, to design approach and schema design, to query fine-tuning, and to even feature scalability. So again, having a holistic view on the performance fine-tuning allowed us to kind of create excellent results in the end. So let me take you through that one after the other. So let's start with doing infrastructure sizing and capacity planning. Now, here one of the key learnings you had is that SSTs, provide a very significant performance boost when specifically for write-heavy loads. And on the ETL side of the subsystem, we essentially were while we were doing the sizing of our instances, we kind of made a little SSD heavy there. Right? We also learned that of course the investment in CPUs with more cores often delivers more benefits than investing in faster CPUs. Remember, the MongoDB has been designed to be to scale horizontally. So in that context, that again is another interesting parameter. Now, one of the things is essentially how we design our instances. When we have the Amazon or cloud instances, how do we choose the right parameters for those? Now, in this case, let me give you two extreme examples. The ETL subset, ETL subsystem was very CPU was very they required data processing. So a CPU heavy system would be more appropriate there. While on the front end, which was more analytics heavy, we would require a RAM heavy because of the indexes and stuff which had to be stored in real time and getting a real time response there. So again, those considerations are very important when we are doing the infrastructure sizing and planning there. We need to ensure that the working sets fit in the RAM. So we recommend use of db.server status command to view an estimate of the current working set size. So make sure that we kind of size the RAM and indexes kind of pretty much in lockstep with each other. In terms of journaling, we believe that we should evaluate it very thoroughly whether journaling is needed in our use case. Because turning the journaling on would essentially double the RAM requirements there. And of course, on the cloud capacity planning, again, look at what the right instance size by evaluating the access patterns and making sure we're picking up the right instance. And again, we did this particular implementation for a startup, so the sensitivity of the cost was very high. So in that context, picking up the right instances rather than oversizing or undersizing, and it allowed us to kind of keep the costs optimal. So moving to the next slide, on the OS and storage optimization, we, based upon our experiences, we strongly, in fact, in 3.2, MongoDB WireTiger is turned on by default. And we strongly recommend using WireTiger as a storage engine because of just the performance gains, both on the storage, the disk storage side, as well as the write access time, and as well as the multiple optimizations that does for indexes and so on. We strongly recommend WireTiger as a storage engine for MongoDB. There are certain OS optimizations which we kind of learned the hard way. I mean, obviously there is a white paper which MongoDB has now, but we kind of learned it the hard way. We set the default configurations on our instances, and we were essentially getting some performance bottlenecks. So here are some in terms of disabling NUMA. Strongly recommend disabling NUMA, non-uniform memory access. So if you configure memory interleave policy in your operating system, or instance, it automatically disable NUMA, and that would essentially give you right performance for MongoDB. A lot of times, some instances from virtual faulting point of view, virtual memory pages, they use huge pages. We recommend not to use that because MongoDB recommends not to use that because Mongo performs better with the normal virtual memory pages. Then there are certain guidelines of reader head size should be set to 32. There are certain, recommendations on increasing the limit and so on. So really, it's important, again, from a holistic standpoint to look at all these things upfront rather than getting stuck and then kind of trying to figure out how we can kind of, make some, tunings here and there. So with that, moving to the next slide. In terms of schema design, we strongly recommend investing good time in optimal and very sophisticated schema design. A lot of times I hear from people saying, hey, MongoDB is schema-less or dynamic schema. Well, running schema only means additional flexibility. You cannot compensate for a good schema design. So always invest time in a very, very optimal schema design for your use case and application. There are a few smallest guidelines, but the results of these are phenomenal. Do not use empty fielded documents. Very, very inefficient. Create indexes very carefully, and more indexes do not always mean more performance. In fact, indexes which are not going to fit in the RAM are going to be very counterproductive for performance. And in terms of index creation, when do we do the index creation? Never do it on the fly. We essentially have a very structured policy of doing it during the maintenance window so that the loads are optimally maintained. We've used, in fact, another key learning we've had is we've used the bulk API feature in MongoDB very effectively, and we recommend using it wherever it's needed, wherever it's possible. We've actually witnessed very significant gains in the write throughput using that. And I mentioned this earlier, index optimization of wide storage is a boom. Please, always use that, and it's really helped us a lot in our optimization. Moving to the next slide on scalability and query tuning. Scalability, horizontal scaling through sharding, picking up the right shard keys, designing it, designing it right. Very, very important. We actually use MongoDB aggregation framework very effectively. Very interesting feature. And for us, it was a boom again because in our ETL process, it was a very pipelined, kind of flow, a multi-step ETL process. So which meant that output of one is feeding into the next and so on. So so without aggregation framework, I don't know, it would have been very inefficient way we would have done that in custom code. But aggregation framework works beautifully for us. So wherever there's a requirement of using, do use that. Next on the scalability is non-functional requirements, the NFRs. So NFRs are essentially, our learning has been that NFR should be kept on top from the day one. It is not an afterthought that you design something, best possible way, and then say, okay, we'll look at the NFRs of a sub 2-second or 3-second response time on the web application later on. Absolutely not. These from day zero designed for that, and that's how. Otherwise, you can avoid a lot of hard runs basically. On query tuning, obvious one is using effective indexes, effective use of indexes to support queries. In our experience, avoid negation in queries and static other queries. That's bad. That's really bad on the part. And another mistake people make regularly is just the default, query results are kind of, if there's a large query result being returned, and if you already know what are the kind of, results you're looking at, do use projections. Do use, if you're not really sure about it, at least use limit. In most of the cases, you'll be able to do with a limit, so that you're not going to go overload the kind of when a cursor returns, from the query. So do that always. An effective and frequent use of MongoDB Query Profiler and explain command. Now, MongoDB, we believe is really mature in terms of a lot of the utilities it provides, and we actually these were boom to us. We were very effectively use that. Explain command has been very useful. I think the most often used command in the entire development and fine-tuning cycle has been explain. Using hints there and using explain really helps us understand what each query is doing and how it's translating and how I can optimize my indexes there. Query Profiler very effectively used, and a lot of other utilities like a MongoStat or a MongoTalk or a MongoSmith, very handy to use to do essentially use that for essentially, getting a good picture and help you in performance areas. So with that, I come to my summary slide in terms of, so what are the benefits delivered? So again, a very simplified architecture with the right technology for the use case. And performance tuning and scalability is the key essence of the message over here. Our holistic approach to performance tuning and the choice of technology components, starting with MongoDB, allowed us to reduce the response time on the front-end SaaS application from a 2 to 3 minute kind of in ballpark to 3 to 5 seconds. So all our front-end queries or front-end mining is happening within 3 to 5 seconds. And that's a combination of the optimization we've done to the use to the MongoDB and other things, and also the fact that how we have done the semantic associations to be able to kind of do a very intuitive queries on the front end. In this case, we kind of, one of the challenges I mentioned in the upfront, the first slide, was about legacy and proprietary technologies and how do we kind of leverage existing investments and work with the newer open source / proprietary technologies and how they can coexist. So in that context, we've been able to kind of optimize the overall total cost of ownership of the solution. Next on the list is essentially taking, we believe that the team composition played a critical role, and some of it is also learning on the fly as we learn the hard way. I mentioned about the data quality and adding a business analyst and an afterthought and so on. But again, the key to success has been, a very, very, complementary skill set which the team brings in, from a solution architecture to the DevOps to the business analyst, data scientist, and so on. Having a right, composition is critical to success, and that's what, this learning came in from this. Last but not the least is the optimal leverage of elastic compute storage, and again, we use AWS in this case, and one of the key benefits essentially was because it was being done for a startup, being cost sensitive. So our ability to elastically scale up and down was very optimally used for getting to optimal, pricing or costing, the cost of ownership of some of the solutions. So with that, I think I've come to an end of my, presentation. I will, transfer it back to Buzz to talk a little bit about MongoDB, and we take it from there. So over to Buzz.
And I'm off. Okay, thank you so much, Anurag, for that. Oh, yeah, slideshow. Okay, I'm hoping that everybody can see a slide now that says MongoDB Vital Stats. We've just switched control back to me. I'm going to take a few moments to tell you just very broadly about MongoDB and a couple of the key, just a few of the key technical features that I think have made some of the parts of the architecture that Anurag described really, really shine. But what we see here, and just to kick us off, we are a Silicon Alley company headquartered here in New York City with over 500 employees, most of them right here in the headquarters in Times Square. We do have 24/7 follow the sun support globally, as we see in the bottom left there, including Sydney and Israel to cover Sundays. And we're backed by a lot of very famous names with a lot of money. Now, MongoDB, as many people know, comes in both a community and an enterprise edition. The enterprise edition is a better way to use the product when you're really going to do it at scale. And in addition to having, of course, access to our support structure, there are special things that we can do with respect to the commercial licensing of our product for indemnification and liability, which is not available in some other kind of open source products. You also can take advantage of some of the additional features and capabilities brought to the table by our encrypted storage engine. Things like the BI connector, which allows, or I should say it projects on its top side, industry standard PostgreSQL. So that means that any tool that you've got which can talk to Postgres, which is pretty much every tool on the planet from Cognos to Tableau to MicroStrategy, you name it, can now talk through to MongoDB, solving that last mile problem. And of course, there's security and platform certification and training that can come along with the enterprise edition of the product as well. Now, one of the things, we go back a couple slides, you recall that Anurag had outlined his approach to how they were going to put the data facility together, and steps 2 and 3 for data preparation and modeling were very important parts. And one of the things that MongoDB does very well is not get in the way of how you want to construct and then work with your data. We see here on the screen here a document. This is our row, if you will. It's our unit of work in MongoDB. And because we are schema free, we let the data do the talking. So MongoDB Data, although this is, if you will, a 2-string representation, MongoDB Data is richly typed. So fields can be ints, doubles, dates, strings. They can be real arrays, or as we see here in authors, for example, it's an array of structures. And all of these things are projected through to one of the 10 drivers supported by the factory: Java, C#, Python, Perl, Python, etc. And one of the things that's important about this kind of approach to data modeling and persistence is that you get to treat your data more like objects. And a very, very common pattern that arises in MongoDB is having, I'll say, common data and then bespoke data. So in this example here, the name field, record to record, is always going to have first and last name. But the personal data field, the contents within can be very, very different and very dynamic. Now, make no mistake, all of this material, even if it's different document to document, is still queryable, it is still indexable. But because you can now start to mix things in this way, your designs in MongoDB, as you're going through some of those data preparation and modeling steps that we heard about earlier, instead of ending up with a 200 or 250 table schema that you have to address every time you want to get data out, your physical models inside of MongoDB become much, much more compact. Typical installs in MongoDB only have a handful of collections, maybe a dozen collections, 20, but there's no need to have this fan out of one-to-many tables in order to capture all those kind of data relationships. And especially in the modeling phase, if you miss something, right, you forgot, I'll just making light of it, a favorite pets field. Well, favorite pets, is it 0, is it 1, is it 25? These are the kinds of data modeling problems that make people suffer when you're always having to look at making another table, another foreign key, and another set of joins in order to get the data back. With MongoDB, you can sidestep a lot of that. Lastly, I just want to make a very quick note about what we've been doing with the whole release of 3.0 and 3.2. About a year ago, when we released MongoDB 3.0, we introduced the new Wired Tiger storage engine, and Anurag told you a little bit about the usage of that in their platform. We got compression, we got a great way of using hardware threads. A lot of this still boiled down to the ability to scale vertically. MongoDB's always been very good at scaling horizontally. We still are, but now we offer the choice that so you can also scale vertically. And as a result of that, there are a number of, I'll call them sweet spot use cases that are really beginning to emerge as things that are suitable for MongoDB. In other words, we're beginning to move away from the specialty use cases into more broad use cases. Now, you heard a lot today about big data, but in particular things like product and asset catalogs and single view and complex data management. These are all things that leverage the MongoDB data is the schema paradigm and allow us to do these things so that you can focus on your data, focus on the business analytics behind it, instead of wrestling with the database just to get the data into it. And with that, I will stop and I'm going to turn it back over to Anurag. He's going to tell you a little bit about CIGNEX itself. Okay.
So can you see my slide?
We sure can.
Great. So thanks, Buzz. Appreciate that. So let me take a few seconds to talk about CIGNEX Datamatics. We essentially are one of the number one pure play service providers in the world. We are open source on our sleeve in terms of not just leveraging open source, but also contributing back to the community. Starting with portals, content collaboration using Liferay and so on, from enterprise content management, to e-commerce, and more recently is big data and Internet of Things. We essentially have business engagement platforms. Panoramics is for big data integration and analytics. It's a full-blown platform from a front-end data ingestion to data cleanup and enrichment to predictive models, to model deployment, to visualization. And we've leveraged that for many use cases which we have delivered. Our components of that were used in the use case I presented. And we also used it to build another platform on top of it called Vital Statistics. That essentially we have leveraged for delivering a few Internet of Things use cases. And the key, at the heart of any IoT implementation would be a big data platform. But on top of it, we require a lot of other platform as a service kind of features like sensor provisioning and security and identity and so on. That's where we have built in Vital Statistics. Then of course we have digital employee engagement platform. We have reputation management platform and franchising management platform, which we have so again a lot of platform-centric approach. And let me take you to the next slide of a glimpse of a few big data use cases we've done. And big data IoT use cases we've done. The one I already presented to you was interesting sales analytics. Then we have worked with a leading GPS services company in the world to really real-time data ingestion from GPS devices across the continent, and 200,000 devices sending data concurrently and repeating. And we use MongoDB as well for that, and doing some kind of real-time ingestion of data and analytics around that. Then we worked with a SaaS-based startup company which offered SaaS services around sentiment analysis. So again, unstructured data from Facebook and Twitter, and in terms of what is trending and what are they using keyword-based, and creating a sentiment analysis for different use cases from a legal to a political and so on. So very, very advanced, platform which we've done for them. We also worked with it's a networking company, and their one of the use cases was around their e-commerce e-learning platform, where they were essentially, the trainings were being imparted through that. And the whole idea was to use a real-time switching over from one device to another, whether it's a mobile device or a tablet or a laptop. So again, the whole idea was to create a full-fledged, use case around that, and creating a lot of analytics around learning and so on. So that's basically a quick glimpse of what we've been doing. With that, I'll come to the end of the presentation and move to the questions. So I'm seeing some questions are coming in already. So maybe I'll just take questions which have come in. So for the questions, one of the questions that come in is essentially, what was the data size for the 3 to 5 second response time on the front end? We were, as I mentioned, we were ingesting about processing about 1 billion records on the ETL on the ingestion side. But after deduplication, filtering, essentially, we essentially were storing about 25 to 30 million records in the store. I would say about a couple of terabytes of data from a disk storage standpoint. Next question which has come in is about what is NFR? Oh, NFR is non-functional requirements. This is about all performance-related stuff. We were clubbing under non-functional requirement. One of the NFR was about sub 5 second response time on every query which is filed from the front end. And that was the key in terms of, otherwise anything more than that would disengage the salespeople who would engage on the SaaS platform. So next question is, Okay, so did we compare performance, the MongoDB performance in our use case with the Hadoop or other NoSQL database? That's a great question. So Hadoop essentially, we did not do it because we felt that Hadoop is more suited for a batch mode analytics kind of a run. Any analytics of the batch mode. So we essentially, looked at, yes, we did look at a couple of other, NoSQL databases. And I will not remember exact performance metrics or whatever at this point in time. Maybe, if possible, we can try to dig in later and share it with the email. But we did some analysis at our end. We felt overall MongoDB was a better use case for that. And that's the which was MongoDB.
Hey, Anurag, can I jump in there? This is Buzz for just a moment. And what I want to add is that Hadoop by itself is not a database. Hadoop is a data, at its core, it's a data management platform, HDFS, with a computing paradigm called MapReduce sitting on top of it. And so you do end up, finally, when you go up stack from there with things like HBase, and HBase, as many people know, is very, very performant. But HBase is pretty much good at doing key value kind of data management. Your values are I don't want to turn this into like a database comparison webinar, especially at the very, very end. But it's important if you go to the MongoDB website, or in fact even the HBase website, to critically understand the difference between the document model that we saw earlier and the idea of having rich shape, rich expressive query languages, and indexing options, and how that's different from the way that some of the other key value stores approach the data management problem. There is one here that we saw that came through on our side, and that is if MongoDB allows you to store any shape of data in a collection, then how do you govern that? And the answer is twofold. One, and we didn't go into it in detail today, there's a concept in MongoDB called document validation. And using basically our own query language but turned upside down, you can apply an expression to a collection such that if a candidate document to be inserted or updated meets that filtering expression, then it will be admitted to the club, so to speak. Otherwise, it will be rejected. And you can both, you can be as restrictive in that expression as you want, essentially to cover every kind of field, or as we saw before with the name and the personal data example, you may want to say that name is required, personal data is required, but the contents inside of personal data are allowed to be dynamic, and then you let your software handle it. What do you got? Anything else from your side, Anurag?
No, I don't think I have any. Nupur, do you have any questions coming in more?
Okay, we're coming up by, it's 5 minutes to the top of the hour anyway, so it's probably a good point for us to close here. Anurag, since I opened it up, I'm going to extend it to you to close us out today.
No, I appreciate, I think so anyway, okay, it's been a great pleasure having, doing this seminar today with Buzz, and appreciate all your presence here. Hope you found this interesting and leverageable. We essentially, if you have any more questions, then we would, we can, we'll gather. If there are more questions coming in over the next 5 minutes, we will try to kind of respond back on email. We have all your emails, so we can respond back on emails any more questions which come in. And besides that, this recording will be available in the next 24 hours, as Buzz pointed out. And again, and on behalf of Mongo and MongoDB and CIGNEX, thank you very much for participating in today's seminar.
Thank you, everybody. Goodbye.
Bye. Bye.